factorizing, just as a reminder, when we come to assignment 1, which is the algebra assignment, that's really preparing you for that. So some of the terminology around it. This whole thing is called an expression, because it's got no equals sign in it, so there's no equation to solve. It's got no equal sign, therefore it's not a formula involving symbols. It's an expression. It's the way we write something algebraically. So in an engineering environment, this could be, say, an expression I'm going to put into a computer to represent some dimensions. I'm going to measure a dimension x of a piece of material and a dimension y, because remember x and y represent numbers. And I'm going to times x by 5 and times y by 10 to multiply up, say, some component size. And then add them together to get an overall dimension. So an expression to say what I'm going to do, the sort of thing an engineer might do to put some into a computer or into Excel or something. Each of these, within this expression, I've got two terms. So that's a term and that's a term. So expressions involve terms, and then within the term are elements. So the 5 and the x are elements within that term. I'll tend to use these words. It's not crucial that you know them, but I'll be using these words. So when I ask you to factorize something, what I'm asking you to do is to remove a common element from each of the terms that's in the expression. So you look at the terms, x and y. X is not common to both. Remember, x is a number, so the number x is not common to both. The number y is not common to both. But the number 5 is common to 5 and common to 10. That means it's a multiple, or it's a factor of 5 and a factor of 10. So I can take 5 outside the bracket. So what does factorize mean? It means put in brackets by taking out a common element. Now, people often stumped on what goes in the bracket. So what you do is you ask yourself the question, what have I got to do to the 5 to get 5x times by x? So that's what's in the bracket. Plus, what have I got to multiply 5 by to get 10y? 2y. Done. Factorized. Okay? If you look at this process going from there to there is called factorizing, and going back again is given the term expand. And if I expand this bracket, in other words, I multiply what's inside by what's outside, I get 5 times x is 5x, and 5 times 2y is 10y. So if you're asked to factorize something, which it will be done, has to be in the first assignment, you can always check you've done it right by expanding, once you get back to the original expression. Okay? So if you got that one right, well done. Number 2, what is the key thing you've got to do here? Find a common denominator, which in this case would be right. So in other words, what I'm really trying to do here is to make sure I'm adding the same thing. I can only add things that are the same. So therefore I'll end up with 12. So I want both of these in the form of 12s, so then whenever I've got 12s. So now what I've got to do is think about converting this to 12. So I ask myself, what have I got to times a 3 by to get 12? 4. So therefore I must times the top by 4, so that I've not changed the fraction. So 4 2s are 8. I'm looking at it, 2/3 is the same as 8/12. Similarly, what have I got to times 4 by to get 12? Thank you. 3, right? So what do I do to the top? Times by 3. 3 1 to 3. And now I can add them. Don't add the bottom numbers, that's just what you're adding. So I add the 8 and the 3 to get 11/12. Now, look at this one. Okay? X and Y. The reason why I'm hanging on about these fractions is that they come into algebra. X is a number, Y is a number. I'm after a common denominator. What did I do to find that the common denominator of that was 12? I multiplied it together. 3 times 4 is 12. So what's the common denominator of these? XY. So I need to convert this to XY and this to XY, and then I'll end up with some term over XY. Exactly the same process. What have I got to times the X by to get XY? Y. So what do I times the top by to get 2Y? What goes here? 3x. What have I got to times the Y by to get XY? X. So times the top by X. And now, still on question, whatever, I'm just expanding on it, Michael, okay? Now I've got to this, I've got a common denominator, so I can then add these at the top. But all I can do is add 2y plus 3x, because I don't know what x and y are, so I just have to leave this 2y plus 3x, okay? That's how that might be used in an algebra question, that idea of adding fractions by finding a common denominator. Questions? Sure. I've lost my mic. Oh dear. So any questions on that? At what point did I lose it? Okay. Anyway, so moving on. Question number 3. Calculator question. Calculator question. So if you've got your calculator to hand, what I would do is I would hit the square root button and then I'd hit the fraction button. And then I'd get, just one sec. Then you can put it in literally as you see it on the page. You don't really need to put a bracket round the 15.62. It would be enough to go 15.62 and then hit the x squared button to get 15.62 squared. And that's exactly what you should see on the screen. And then underneath, literally type in 29.61 and then hit the square root button again. And then, sorry lads, so square root 10.53. And then that's the beauty of those calculators. You actually see on the screen then hopefully what exactly it says on the page. If you've not got a calculator that does that, and you're happy with yours, fine. But if you're not, then you need to buy one. And actually someone was saying that in Tesco's at the moment they're £1.95, a special offer. So get yourself down to Tesco's. Probably not the one in town because that's a bit small, but a big one, you might get one, okay? And then you hit equals and you get, somebody? 1.604 to 4 significant figures. So excellent, okay? 4 significant figures is appropriate in this case because there's 4 in the numbers. Formula for the area of a circle. Pi r squared. So what I'm going to do on the calculator is put in, hit the pi button, times by the radius, which of course is half the diameter, 25, squared, hit the squared button, equals 196.3.5. Appropriate accuracy. We've only got 2 significant figures here, maybe 1. So really a little bit over the top. So 2,000 to 1 significant figure. Or, guys, at the back, have you got a question? You're worrying about this one? Right, okay. Or to 2 significant figures, what would it be? Right. That's an important thing. When you get out into an engineering environment, I was actually just doing this before you came in with some of the foundation degree students here. We were talking about this and then taking it outside. You're calculating forces on materials like metals, which you'll be doing. It's no good giving massive accuracy to these things. You need to give someone an idea of just how accurate your answer is, so they've got an idea of the tolerance. That could be 2,000 plus or minus 500 newtons if this was a force. You need to know that. If I'm giving this accuracy, that's 2,000 plus or minus 100, so 50 odd rather, so that's 2,000 plus or minus 50. So I'm giving a much greater accuracy here to here. So it is an important issue. It's probably something that many lecturers won't bang on about, but I need you to think about, okay? Okay, next question. Number 5. Rob, focus on this, please, because you're disturbing. Density of a block with a mass of that and the volume of that. Anybody know the formula for density? That's forces mass times acceleration, I think you're thinking of. No, mass over volume. Mass over volume. Mass per unit volume. We measure it in things like grams per centimetre cubed or kilograms per metre cubed. Yeah. So let's look at this, okay? Density, mass over volume. There's a few things that is worth pointing out to do with this particular formula. If you know the formula, you know the units, because we measure mass in grams and cubic centimetres, grams per cubic centimetre, or we measure mass in kilograms and volume in cubic metres, so kilograms per cubic metre. Note that the formula is giving you the unit. That's the first thing. So if you're not sure of the unit, it's given by the formula. Thank you. So, and the other key thing to come out of this is you can't mix these units up. We do not conventionally measure density in grams per cubic metre or kilograms per cubic centimetre. It's that or it's that. So if you look at the problem you had, we've got an issue with units, and that often arises when we're calculating things. You have to think about the unit that's involved. Are they consistent? Are they correct? No, they're not. So I've either got to convert cubic centimetres to cubic metres, which is not straightforward because there aren't 100 cubic centimetres in a cubic metre. So 100 times 100 times 100, which is 1,000,000. Or I convert kilograms to grams, and there's 1,000 grams in a kilogram. So to do this question, I'm either going to go 2,462 grams over 173 cubic centimetres, or I'm going to say 2.462 kilograms divided by, I've got to divide this by a million, so I take the point back 3 places, is 1,000, 3 more, 0. Either of those answers will be correct. This is in grams per cubic centimetre. This is in kilograms per cubic metre. Now, I cannot overemphasize the importance of this in all your other topics like engineering materials you'll do, mechanics. This sort of thing comes in. Consistency with units. Any questions, anything about that conversion I just did that you weren't sure of as I was doing it? Okay, I'll just pause while you make a note of that. And then. So final thing on this, if I do this calculation, if you do that for me, this one and this one please, and then write your answer to an appropriate accuracy. So if you've got your calculator, just do that. So what do we get this one to be? Grams per cubic centimetre, yeah. Accuracy, what have you rounded it to? 4 significant figures, don't forget to quote that. Or what about this one? The 4 significant figures. Okay? Not relevant to this particular unit, but very important to you as an engineer, and I'm trying to keep that in mind all the time. If you're converting from grams per cubic centimetres to kilograms per cubic metre, what do you do? Actually, is that right? Let's just pause that. So, yeah, still 4 significant figures. That 0 is just there to hold the position. But to 4 significant figures, 0.
Isn't it supposed to be the lowest number?
Yeah, so you could you could easily quote 3, true, but it's 3 or one more. So 14.2, 14,200 would equally be good, yeah. So 3 or 4 significant figures, not more, okay? But note, if you want to convert from grams per cubic centimetres to kilograms per cubic metre, what do you do? Yeah, times by 1,000 effectively, move it 3 places. And that's worth remembering, okay? Times 1,000. If you look at this, and this is the maths behind that actually, to get from grams to kilograms, I divide by 1,000. To get from cubic centimetres to cubic metres, I divide by 1,000,000, and so I actually end up, if you think about the logic of it, multiplying by 1,000, which is where it comes from. So if you want to think your way through that, you can see it, okay? That's an important little aside, really, not really to do with this unit, but you'll be certainly coming up with those sorts of problems in other things that you're doing. Right, number 6. Mean, mode, and median. Mean, well, oh, not getting one, because it's only an hour and a half. And we've lost a quarter of an hour before you came in, that's an hour and a quarter. So, mean, add them all up, divide by how many there are. Note what this is symbolically, please. You probably, if you've been looking ahead at the chapter that I asked you to look at, chapter 37 it was, or whatever, to do with means and averages, this is the formula that you'll find for the mean. Sum, that symbol there is the sum of the frequency times the values. So that means, algebraically, add up all the numbers. And divide by the numbers they are is the sum of f. So sum of fx divided by sum of f gives us the mean. Mode, most common, most popular, most frequent. Median, yeah, middle value when placed in order. Good, okay. In your assignment 3, you're asked to find those 3 averages. And you use that little formula at the top there. Number 7, anybody remember Ohm's law? Okay. Yeah, that's it. V divided by R is I. Yeah. Of course you can, Rob. So, rearrange Ohm's law for current I equals V over R. Or V over R equals I. Okay? Out of 7. Yeah, leave it open, Mike, that's fine. So, give yourself a mark out of 7. Some awkward questions there, so, don't worry if you didn't do fantastically well. will you, just the question is, could you do it next time?